Okay, in this video we're going to talk about the change of base formula for working with logs, and we're going to start off by stating it, and then deriving it, and then do a couple of examples. So let's see what it is. So the change of base formula tells you that the log of b in base a is equal to so log of b in base a is equal to the log of b in base c divided by the log of a in base c, which means you can pick pretty much whatever base you want. C has to be positive and it can't be 1, which are the same rules for any log. But otherwise, that's what it is. And I will say that I tend to use it more going from the right side to the left side than the left side to the right side, except in calculus. But that's it. That's the entire formula. So let's take a look at where it comes from. So what we do is we start with the log of b in base a is equal to k. And now what I'm going to do is I'm going to exponentiate, so I'm going to take from log form to exponential form. So a to the k is equal to b. And now I'm going to take the log of both sides in base c. So I'm just doing the log base c of a to the k equals the log base c of b. And now I'm going to use on the left-hand side the property where exponents become coefficients, so I'm going to bring the k down. That's a very common property to use. So k times the log base c of a is equal to the log base c of b. And now I'm going to divide by the log base c of a. So k is equal to the log base c of b divided by the log base c of a. And since originally we said that k was equal to the log base a of b, we can kind of finish this off. So the log of b in base a is equal to the log of b in base c divided by the log of a in base c. So the way that I visualize it, the thing on the top kind of stays on the top and the thing on the bottom kind of stays on the bottom. So b ends up in the numerator and a ends up in the denominator. Obviously a log isn't really a fraction, but the right-hand side is a fraction with logs. So that's how I've always remembered it, and it helps me out. So let's take a look at two examples. And there's really not much to be done with these. So we have the log of 23 in base 6. So that I can rewrite as the most common thing is use common log, which would be base 10. So this is going to be just the plain old log of 23 divided by the plain old log of 6. And this was a big deal when calculators didn't have a template that let you just punch in a log, because you would have the log of 23 in base 6. And to get a numerical approximation, you basically had to use the change of base formula. But now that's not so much the case. And let's take a look at another one. So we have the log of 13 in base 5 divided by the log of 26 in base 5. A really common mistake that people will make is just to try to magically turn this into the log of 1/2 in base 5. I think they just do 13 divided by 26. But that's not how it works. But you can see since there's already the same base, they're both base 5, that's what lets this work. So they're both base 5, so we can change this into the log of 13 and base 26. This, in recent years, has kind of become the most common way that I use this. I'll solve an equation using logs, and I'll get an answer that has some arbitrary base, like I didn't know what base to use to begin with, so I use base 10, or I'd take natural logs, which is base e. And then at the end I want to get it back to match a solution or something, so I'll use change of base formula to kind of condense the answer that I get. So I want to show you one more thing, which is kind of a really interesting property of logs, and it looks kind of like magic when you see it. So what we're going to do is we're going to start with the log of b in base a, and we're going to use the change of base formula, but I'm going to be really specific when I make my choice. I'm going to use base b. So I'm going to change this log to log base b. So it's the log base b of b over the log base b of a. But then if you remember, the log of b in base b is just 1 because b to the first equals b. So this is actually equal to 1 over the log base b of a, which means if you look at overall what happened here, we started with the log base a of b, and we equal that to 1 over the log base b of a. It's like they switched places, but it also went from the numerator to the denominator. It looks like everything just kind of switches around. That's just a property that I really like. And okay, so that's the change of base formula. I hope you found this helpful, and good luck.